Good morning, everyone. My name is Moser, and I would love to talk to you about the Echidna pattern. This is something I came up when I was in my consulting engagements with customers because they got stuck in their platforms, and in the end, we had severe refactorings, or in 2 cases even that the company did not get more investment and went bankrupt. So once upon a time, there was this happy group of developing people. So what they did is they created a nice platform or product, and they were super happy about its release. So the happy party of developers, they successfully launched their product. That's what we learned, especially in startups or in also internal project, nothing that is just common. They also marketed properly. Everyone know about that these platform people built these awesome products. Well, and actually people liked it and they started using it. But as we know, that can happen that they come and say, oh, that would be awesome if my system also could be integrated in your system, or if we could have data from you, or could we do this, could we do that? And suddenly, that's what happens. The evil wizards of external requirements came. And what did they do? So basically, they wanted audiences with your developer group or your project manager, and they came with extra requirements. And because these people were a nice group of developers, they started to implement those features, they adapted the protocols, they created integrations to other systems, and in the end, more and more people came, everyone wanted something, and they became a bit worried. Why? Because their platform, they lost more and more control over it. I think we all had that, or so we're in this situation. You gradually lose the control over your backlog. You have your timeline, you have your backlog roadmap, but in the end, you have external dependencies, and another system comes, hey, yeah, we updated an API, and basically in 3 weeks we go live, and please can you update your integration, because if it breaks, people are not happy. You try to avoid that. But that makes everything more complex. Starting with testing, if you create a feature, you need to test it with all the contained systems. You need to make sure that all the integrations still working, that nothing breaks, and everyone is still happy. By doing so, your velocity is also dropping and dropping, because you have firefighting, external dependency things. You're basically also dependent on the roadmap of other people, and your own velocity drops and drops. And I see that a lot, and in the end, the people that do it, they are not happy anymore, because they get lost in external dependency, firefighting, the system becomes rigid, you cannot do what you had what you had as a cool idea in mind, and in the end, they also were not super interesting. And in the end, you basically lose your happiness in doing what you do. And what happens then when you put all that and integrate it, it can be that your nice platform becomes a big ball of mud. So, as we all know or should know, that big balls of mud are nowadays not what we try to achieve. They came up with a cool solution. They called the wizards, and they brought up a very nice solution. The solution of no. So, well, how does the solution of no work? You have people that come with a request to you, and all you do is basically you say no. And they come with, can you integrate this? No. We all know that. The problem with this is that works, but it disappoints all the people who want something from you. And if you're not lucky, these people are important stakeholders. We all know the son of the CXO something. And what happened is that if you want to grow your solution, they maybe also say no. So your solutions stay flexible and slim, everything is good, and you have your own backlog, but growing gets harder and harder. And because you say no so often, the people, they perceive you as maybe not really cooperative, and they maybe also do not like you too much after saying no repeatedly to them. And you say, look, you don't want to embrace the change, you will not grow, and in the end, your problem becomes that your platform or your product drowns in the sea of insignificance. That's also not something I think we want. So there must be a better solution. But here, the better solution comes. They regrouped, and what they found out is this one. It's called the Echidna. The Echidna is usually an animal in nature. They don't have these armors, I was told, in the real world. But they have the spikes, and they are really fluffy and nice and cute people. So how does the Echidna then work? And how can it protect our platform or our software? Well, we have some basics. We first say, hey, we protect our core, our application at all costs. It's basically a black box for everyone except us. So the second part is, we say not no, but yes, but. And how is that but? We say, yeah, you can interact with us, that's no problem, but we give you two options to do so. First, APIs. It's nothing new. We say, look, if you want to receive, provide, or modify data, and you initiate the communication, we give you an API, you can talk to us, no problem. On the other hand, they say, but I need to know, for instance, in a platform, when a GitHub repo or a repository is created, that we want an event, we want to be notified, maybe put this in a Slack message and say, hey, your repository has been created. So this is the hook thing. It's basically the server invoked version of that. In the server, we say, okay, something happened. We have endpoints from customers, external dependencies, which we notify about that. So these are the two ways people from external can talk to us. Everything else, we say no. And if that, with this, we can also have an anti-corruption layer. And with this anti-corruption layer, we basically can either further contain our domain without getting poisoned or corrupted by external systems. That means in the end, we do not care where the data comes from to our core platform. It can be MCP, it can be REST, it can be GraphQL, it can be JSON, it can be XML, we don't care. We just get the data from externally into our system. So what our new strategy is, hey, you can talk to us, touch me gently. If you don't, get hurt. This is basically like the Echidna looks in real world, no armor. But if you make it feel anxious, it basically curls up like a hedgehog. You see all these spikes and you get a really impressive experience on how not to do stuff. So how do we do that in software? We saw now a nice fancy heroes doing stuff, but if we do that in reality, how would we do it? So basically, we have here somewhere our extended domain, maybe easier with the fingers, huh? In the extended domain, this is your application core, and as you can see, we do not care in what architecture, technology this is. That can be microservice, monolith, it can be a monolith, whatever you use here. Then we have the core layer, and we do not want directly to talk to the external systems because they're in the great wide open, they're dangerous, they're not nice, and have their own roadmaps. How can we prevent then that we get corrupted? We basically say, okay, our core is sacred. We want to talk to the external systems via an infrastructure layer. And in this infrastructure layer, we have the API controllers where the client-invoked communication comes in, and we have server-invoked channels where we can notify external systems via hooks. That can be anything. I mean, Signal R. You can also use, instead of APIs, message queues or stuff like Kafka where you can stream the events. That's up to you. This is the easiest solution in here. In a, let's say, enterprise domain that would maybe look a bit more complicated, you will have also networking structures that would prevent the core layer ever to go to the internet or to access those external resources. In this case, the infra layer can abstract that. You have here the ACL, that's just short for anti-corruption layer, which basically protects the core from the infra layer. Here, that can be GraphQL, that can be XML, this can be REST, that can be JSON, and maybe this is MCP in another protocol. What we do is we translate in the ACL the protocol into the domain language of the core. The core does not care. The core does not care where this data come from. They just want to do their job. The program parts here, they just interact with itself. They do not care about the external world. And the external world does basically just know how to process this one system call or this one technology that it uses, but it does not know about how the application core needs its data. So that's the job of the ACL. Needs to get this one back. So if you look again at what it is, the thing is, the Echidna is in a system design pattern. We do not care in what technology or how you do it. I mean, those API layers, that can be an API gateway. The ACL, that can be one class. It can be a monolith. It can be several services. If you host it on Kubernetes, if it's virtual machines, banks love virtual machines. So then that's a system pattern you can use. You can adapt this to everything. The second part is we have a core system, which is the heart of the platform. That means we cannot touch it from the outside. That's our own roadmap. We say what feature comes in there, in what pace we do it, how we fix. It's our CI/CD pipeline, our programming language, and our architecture scheme. The outside world has not to care about this, and we do not care about the outside world too much. We have the anti-corruption layer, and this one basically helps us that we can do our thing without caring about the outside world. The anti-corruption layer transforms the outside references and the outside communication protocols and data to stuff that makes sense in our core domain. Outside the anti-corruption layer, we have the API and hook system, the infrastructure components, and those basically know how to handle their protocol. Maybe one client, if it's a special client, they also make sure that they have, for instance, mutual TLS in their web servers, that they say only certain clients can talk to us. And last but not least, we saw that in the top, we have an IAM and a webhook registration service to limit access to defined user groups. Most probably, when you build your platform, you do not want outside people to be able to connect to it. So that means you have some form of authentication, and that can be like API keys, that can be certificates, whatever you use. And for this, you need an IAM system. In the graphic before, it was shown that the domain has one. In an enterprise context, maybe you have one for external systems. That depends on your setup. The webhook registration service is basically, even if you have a webhook system, so that if you create a fully asynchronous communication, where you can say, okay, I just register on GitHub or on repository created, please call this API of mine and send me the data. This is what the webhook registration service would help. Also there, you can limit this so that not everyone can get notified. Maybe your competitor should not know when you created a new repository. The last one, that's sounds like an easy thing to do, but do not overdo those hooks and services. The APIs, I had a customer and we gave them a homework and said, okay, you have 2 weeks, this is your system, can you please specify all your APIs and hooks? And they say, yeah, no problem, no problem. So after 2 weeks we met, and I said, yeah, we did everything. We have like 230 APIs and around 600 hooks. And we said, okay, and how do you manage that? Oh, we don't know yet, but that's what we need. We then took another week with intense communication and found out that in the end they need maybe 40 APIs and maybe 60 hooks. So make sure that if you create those hooks and APIs, do not overdo it. I mean, the managers and external people, they want everything. Oh yeah, we need to do this as well, and this and this and this as well. But as we saw in the keynote this morning, build for the 80%. And they usually do not need that. And if they need, they should give you a good reason. So let's now come to some legendary artifacts of the Echidna, basically some of the basic things we need when we want to try an Echidna pattern. First is the book of spells or contracts. If you have API and hooks and you want them to be used, you need to publish and communicate and maintain your contracts, or at least establish contracts. If you don't do that, I mean, everyone comes and, just want to send data. How should I do it? And in the end, you create so many variants of your API that it's unmaintainable. For APIs, I would recommend that you use an open API standard, or you can also create a client SDK. If you don't know what your clients will be, I would go for open API as it's easy to maintain. You just generate a server for that. And if you have a very specific set of people, you can create a client SDK. But keep in mind, the SDK means you need to maintain that. So it's a lot of work, or can be a lot of work. For the hooks, I would recommend something that is called SPI, Service Provider Interface. For those of who do not know what this basically is the same as an open API standard, but instead of you implementing the server, you say, I implement the client, but please, you create the server, and this is how it must look. So basically, we use mostly open API for this as well. And then instead of, like in the first API case, we create the server, we create the client, and the client or the customer creates the server in this case. So then you have, again, a maintained contract. And if you have, again, special user group, you can create SDKs, but again, you will have to maintain those. And now, that's very, very important. All contracts need, first of all, proper versioning. If you don't version them, you're lost. You will firefight all your life. And second, and that's, I think, the most important, they need a life cycle. And make sure that the life cycle is on both sides communicated. Technically, I mean, you have one life cycle, but your marketing people or your people that create contracts with customers need to know about that. I have one customer, they have this life cycle, the technical life cycle is 1 month, so they release a new version of the contracts every month. The problem is their marketing team, they said, no, we do that every 4 years. So what we had, our customer that came with version 12, and we were at version 60, and everything needs to be backward compatible due to limitations in those contracts. So they had a contractual basis with their customers, and their customer just had to update every 4 years. Otherwise, we could ask them, but they can say no. And unfortunately, they said no. So make sure that your life cycle is short. I would say 1 or 2 versions back if that is possible. So you can keep your backward compatibility limited. If you have to do that, the wider you create your life cycle, the more nightmarish it becomes, because you have to backward and backward and backward be backward compatible for many years. And in the end, create the schema, because I saw that as well. We said, yeah, we have a schema, and what is in your contract? Oh, it's a payload of type object. And what is in that payload? Oh, that depends on the client. Sometimes it's a JSON, sometimes it's a string, and we have also some clients that put in this payload an XML document. So, well, it works. You just put the factory then after, or something that basically can parse that schema and create you something useful again. So if you do that, JSON schema is here for if you have XML. XML has a schema. You can also use, if you use event-driven architecture, something like Avro or Protobuf or whatever you would like to have to basically define how your messages should like, also what type range it should allow. Because if you tell already your customers when they send the data that something is not wrong, it's for them less annoying that if they find out after they sent you the data and it gets processed and something is wrong. So the contracts, they enabled you to stay in charge of what the people can see from your system. So make sure that this is really something you invest time in and that you're also maintaining it. The thing is, if you maintain that properly and communicate it properly, that's something else. If you don't communicate this properly, you have cool versioning, you have a good life cycle, but still no one reads your newsletters or needs the upgrade. Believe me, they come, everything broke. Now you have to fix it back because our system integration is not happy. And in the end, because the people now use your system, it is your fault and not theirs. The second one, the shield of corruption, the anti-corruption layer. So in the anti-corruption layer, we make sure that we stay independent from external dependencies. That means if, let's say, your CEO comes, hey, I heard about this MCP protocol. Now everything needs to be MCP or MCP enabled. Easy, because you can just create an MCP server for that. And in the end, translate it via the anti-corruption layer into your business domain. That means even you add a new way of communication, you do not have to change or test for especially your internal application anymore, because the anti-corruption layer, they protect you from that as soon. Or if you, let's say, have first name and last name get sent, but your system wants to have a full name, which is first name and last name, you do not have to change this in the internal application just because an external dependency wants it in 2 separate fields. The layer also helps that only domain validator can come in. Let's say you make some mistake, but in the end, you can see you have a value range which could be numeric. The API accepts the numeric, it's correct, but your value range is -100 to 100. They send 500. You can, as an additional layer, protect and shield your domain. And also, if you do that with a service, you can create with the connectivity that it is physically abstracted from your domain core. And also, that the core data does not know about the outside. They do what they do best in the way they do it best. They do not want to care if JSON or XML or whatever. They use their own data objects, so make sure that in the anti-corruption layer, you basically translate the protocol-specific data or the client-specific data into the core domain's objects. But be cautious if you have stuff like this. And then often people come, but this is so much boilerplate code because it creates more code. Can we not just do a plugin? They say, yeah, look, cool. We create a plugin. As you see, it gets purple again. Why? Because the plugins, in my opinion, are a fallacy. Because if you have a plugin, it lives still in your code base. And depending on how you do it, the people just send you code. You don't know how their quality assurance was. You don't know how their code quality is, and so on. But it lives in your application scope. Means if that is aggregated or constructed by a system and it crashes, your system is affected. That means if they create an endless loop or it crashes and it takes down your whole application, you need to think of all the possible things that could go wrong with this plugin. So if you do that, in the end, your benefit is not here. If you have an API, if you have hooks, that means you do your thing, and if you crash, I don't care. I still am viable. If I crash, of course, then there's another situation, but it does not solve your dependency problem if you use the plugins. It sounds nicer maybe, but it does in the end not solve your problem. And if you can, try to avoid plugins and external modules. Why? Because they just do not, they bring you problems into your code base that you have, again, less or no control of. But if they say, yeah, that makes really sense, consider to take this over and incorporate it as a dependency in your code base. You get in response, or you are responsible of that again. And that means you adapt your CI processes, your quality things to this code base. The plugin, that can be written by anyone, and in the end, you have to think and have to debug it, because you will be the person that gets the call if the stuff breaks, and you will have to debug and fix, and then you can say, yeah, it was that plugin. In the worst case, you just can disable it, so it just gave you a lot more work. And so, if you do all this, they can be all happy again. To do that, make sure that the Echidna, again, helps you, that you can stay in charge of your code base and you do not lose the flexibility. It's a design pattern. It's similar to ports and adapters, if you have seen that. But it's a system design pattern. It's not how you write your code, or it does not limit you to a certain architecture part. We try to have APIs and hooks. We have versioned them. There's a schema and the lifecycle. And try to keep the interaction points as low as possible. You save a lot of time if you do so. And for last, the fallacy of the plugin. Do try to avoid plugins. If that is not avoidable, try to incorporate it in your plugins. In your code base. And so by that, your code base stays neat, everyone is happy, and that is the end. Thanks a lot for your time. My name is Moser. And if you want to connect, this is a QR code that should go to my LinkedIn in case you want to connect. Are there any questions from your side?
So one thing, whenever I create an open API specification, I had discussions, do we create the YAML or the JSON first, and or do we create it from annotations? So what is your opinion on this?
My opinion is always specification first, because that has it's like doing the tests after the code. I'm also more doing the tests first, because that makes me think about what do I want to expose. And second, usually I do an API to connect two parties. And if I have the interface first, they are unblocked. I can do the server part. There are many things. You can generate a client. You can create If you use something like WireMock or so, you just can upload it, you can create a mock, so the parties are unblocked and can work on their stuff, and then later when they're done, the integration can be done. Otherwise, you always need to wait first until the backend or one part is done. No problem. There was another question.
In your principles, how to invoke you, you said that you only that you basically shift the burden of integrating the API to others. But isn't this is a standpoint that not everyone can take, isn't it? Because if everyone doesn't want to integrate an API, no API ever gets integrated. Why would you say that you can do this, but others have to integrate your API? What is your argument there?
I don't, maybe what do you mean with my API? I mean
Well,
my API.
before you said you integrated the APIs of your clients and you were unhappy basically. But now you're saying you're publishing an API and your clients have to integrate that. Basically, you shift the burden of API integration to others.
Correct.
So
Correct.
if they say we don't want to integrate an API either, then no API ever gets integrated.
Correct-ish. The thing is, in this case, they want something from you. So why should if you want something from me, why should I integrate your API instead of I say, yes, of course, here is my spec, you can implement it my way. You have the things I expose to you, the workflows I provide to you, correct? The other thing is maybe, or what I saw, especially in banking, they do not have APIs. So what they have is, hey, we have this code spec, which maybe works or not. Can you not just create some magic and then call us directly or have some go in a monolithic? A lot of that is also still monolithic. Can you not go in our code directly? And then they started, we had that and they started changing it. And in the end, this team was just firefighting to keep up with those people because they did not care about, for them, you were one of their system, but you had a lot of work to integrate this, and that multiplies a lot if you have not a proper integration of that. Does that answer the question?
Yeah, thanks.
Okay, thanks. Okay, then thanks a lot for your time and have a good day.